welcome to the deep dive. Today we're jumping into something that, might sound technical, but honestly, it's really key if you care about how good software gets made.
Yeah.
Built well, built efficiently.
Without those nightmare bug hunts later on.
Exactly. We're talking open source automation testing tools, looking ahead to 2025 based on the great sources you sent us.
Right.
And our goal here is really to cut through all the info, pull out the core insights, maybe find some surprising facts along the way.
Yeah, and automation testing, just to quickly frame it, it's about using software, specialized software, to check if other software is working right. Is it solid? Is it doing everything it should?
Okay.
And these tools, they're vital, like right from the planning stage through coding, testing itself, and even logging the problems, the defects.
Yeah, right.
And open source specifically, it's carved out a huge space here, really significant advantages.
Okay, let's unpack that straight away. What exactly makes a tool open source? How's that different? And, why should we care?
Good question. The core difference is right there in the name. Open source means the actual code behind the tool is freely available. Anyone can look at it, change it, share it.
Okay.
Which is totally different from commercial or, proprietary tools where that code's locked down. Now, open source might sometimes lag a bit on, say, guaranteed updates or super fast bug fixes, or that 24/7 support line you get with paid tools.
Sure, that makes sense.
But the flip side, the massive advantage is customization. Because you have the code, you can literally tweak the tool to fit your exact needs, which is, incredibly powerful if your team has specific, maybe unique requirements.
That custom aspect sounds huge.
It is, and these tools, they support the whole workflow, really. Planning, building tests, running them, logging defects, all focused on making sure the software is, firm and thorough.
Okay, so looking at the sources, wow, there are a lot of different tools mentioned. They all seem to do slightly different things. It feels a bit overwhelming at first glance.
It definitely can be. It's a busy landscape.
So how do we even start to make sense of it all? Is there a way to group them?
Absolutely. Thinking about their main job or focus helps a lot. We can start with let's say, the more comprehensive ones. The tools often used in what people call continuous integration or DevOps.
Right, the CI/CD pipelines.
Exactly. Those automated workflows that build, test, deploy software constantly helps teams get updates out faster, fewer errors.
Okay, so who are the big players there?
Well, first up, there's Jira Software. The sources often flag this one editor's choice, #1 top pick, things like that.
Okay, Jira, I know that name, but more for project tracking.
Right, but it's evolved. Its power now is how it centralizes and lets you see that whole DevOps pipeline. Development, testing it becomes this single point of truth. It automates building, testing, releasing, all in one spot.
Interesting.
And it connects to everything. Salesforce, Zapier, Slack. So your whole business flow can feed into testing. No more manual data entry messing things up.
That integration sounds key.
It is. And technically, it supports Docker, Git, SVN, Mercurial, even Amazon S3. It can trigger builds automatically when code changes, like from Bitbucket. Plus, you can run tests in parallel batches way faster.
Parallel testing, right? Saves time.
A lot of time. And it has this feature, per environment permissions for deployment. So you control exactly who pushes code to production versus, say, just a test server. Oh, and there's usually a free trial, like 14 days, to check it out.
Good to know. Any other all-in-one contenders?
Yeah, another one it mentioned is Monday Dev. Also very versatile, build, test, deploy. It hooks into Slack, GitHub, Jira, Figma, Teams, the usual suspects. Supports lots of languages too, JavaScript, Python, PHP, React.js. And it seems really good for team collaboration, like keeping everyone on the same page in a shared workspace, even with really complex projects.
Okay, so those handle the big picture, the whole pipeline. But what about just focusing on web applications? That's where so many teams live day to day. What are the go-to tools there?
That's a great point. Web app testing is huge. And there are definitely specialists. Selenium is probably the name most people know. It's arguably the most popular tool for automated functional testing of web apps.
Functional testing meaning?
Meaning checking if the website or web app actually does what it's supposed to do, feature by feature, across different browsers, different platforms.
Right. Why Selenium? What makes it so popular?
Well, its history, the huge community support, that cross-browser, cross-platform capability. It's just incredibly robust and widely adopted. It lets you run tests in parallel, again, cutting down time, needs fewer resources than some others, works on any OS, supports tons of languages, Java, Python, C#, PHP, JavaScript.
Wow, versatile.
Very. And it plugs right into other standard tools like TestNG, Maven, Cucumber for BDD, Jenkins for CI. It fits into existing setups really well.
Okay, Selenium's the classic.
Yeah.
Any newer alternatives challenging it?
Definitely. Cypress is often positioned that way. It's seen as more modern, maybe more aligned with how web development works today.
How so? What does Cypress do differently?
It has some neat features like a really clear test status menu showing passes and fails. It automatically waits for commands or checks to finish, which helps avoid those annoying flaky tests you get with manual waits.
I hate flaky tests.
Tell me about it. Cypress also lets you set the viewport size easily so you can test responsive designs on different screen sizes. It can take snapshots and video recordings of tests, super helpful for debugging.
Oh, video recording's nice.
Yeah, and it auto-reloads tests when you save changes, speeding up that whole write test, run test cycle. Plus, its command log shows exactly what happened step by step during the test. Really good visibility.
Sounds very developer-focused.
It often appeals strongly to developers, yes. We should also quickly mention Capybara. It's known for simulating how a real user would interact with a web app. It has a clean API and a smart synchronization feature. It waits for things happening in the background, so you don't need awkward manual pauses in your tests.
Okay, that covers web pretty well. But the world's gone mobile. What about testing apps on phones and tablets? Similar open source champs there.
Absolutely. For mobile, Appium is a really big name. It's open source, specifically for testing mobile apps, native ones, web apps on mobile, even hybrid apps.
Native web, hybrid, covers all bases.
Pretty much. And a key thing is, it tests the actual app you'll release running on real devices or simulators. It doesn't need a lot of memory. And importantly, for native apps, you don't need a special SDK. It just uses the standard automation tools built into iOS and Android.
No SDK. That sounds simpler.
It can be, yeah. And it supports common languages like Ruby, Java, PHP, Node, Python. So flexible for different dev teams.
Okay, Appium for general mobile. Anything more specific?
Well, there's Selenium. As the name suggests, it focuses specifically on Android native apps, hybrid apps, and the mobile web on Android devices.
Android only for Selenium.
Primarily, yes. It's fully compatible with the JSON wire protocol, which is a standard way testing tools talk, so it integrates well. A big plus, you don't need to change your app's code to automate it with Selenium.
That is a big plus.
Huge. It also makes it easy to find elements on the screen to interact with. And it can handle multiple Android devices at once. You can even hot plug devices connect a new phone while tests are running without restarting everything. Really useful for test labs.
Okay, functionality is one thing, but what about performance? How fast the app or website responds under load. Do open source tools cover that too?
They do. For performance and load testing, Apache JMeter is a real workhorse. It's a Java desktop app originally built for load testing websites, checking their performance. But it does more now.
Like what?
It can stress test different kinds of servers, web servers, sure, but also databases, messaging systems. It saves its test plans in XML format, which is great because you can edit them easily, even generate them programmatically. It's all about simulating lots of users to see where things slow down or break.
Finding the bottlenecks.
Got it.
Now, this might be tricky. Graphical interfaces, GUIs, they change, they're visual. How do you automate testing those reliably?
That is a challenge, but there's a fascinating tool called Cypress. It takes a totally unique approach.
Oh, how does it work?
It uses image recognition. Basically, it looks at the screen like a human does, finding elements based on pictures you give it. It also has something called Control GUI for handling things like standard Windows pop-ups.
So it's matching images on the screen.
Exactly. It treats UI elements, web or desktop, as stored images. This means you can automate interactions with almost anything visible, even if it doesn't have a normal ID or selector that other tools rely on. It's quite clever for tricky interfaces.
That sounds different.
Oh.
Cool, though. Okay, we've covered types of testing. What about managing the whole testing process? Writing tests, organizing them, reporting results.
Right, test management and frameworks. TestLink is a popular one here. It's web-based, open source, great for managing everything. You link requirements to test cases, track execution, manage different projects.
So organizing the effort.
Precisely. You can document test cases, import and export them, connect it to bug tracking systems like Jira, manage user roles. It's about structure and traceability.
Okay. And you mentioned TestNG earlier with Selenium.
Yes, TestNG. stands for next generation. It's more of an automation framework, especially popular in the Java world. It helps structure the actual test code, making end-to-end testing easier. It has powerful features like annotations to define tests, flexible configurations, and good reporting. Shares some goals with TestLink like integration, but operates more at the code level.
Makes sense. Any others in this space?
For Java developers specifically, you absolutely have to mention JUnit. It's the fundamental framework for unit testing in Java. Writing small, repeatable tests for individual pieces of code, it really helps developers catch bugs early. Simple GUI, easy to integrate.
The foundation for Java testing, basically.
Pretty much. Then there's Fitness, which is interesting because it's built around collaboration. It uses a wiki. Testers, developers, even business folks or customers can write test cases together directly on a wiki page.
A wiki for test cases, that's collaborative.
Very. Promotes shared understanding, and it works with Java, C#, Python. Quite broad.
Okay, one more.
Let's mention Serenity BDD. Often used with Selenium for acceptance and regression tests. Its big strength is reporting. It generates really detailed reports with commentary, narrative descriptions of what the test does, and screenshots for every step.
Screenshots are always helpful.
Absolutely. And Serenity helps map those automated tests back to the original requirements so you can clearly see your test coverage against what the business actually asked for.
That traceability sounds valuable. Okay, that's a lot of specific tools. Are there any more general ones, maybe for testing APIs or something for folks who, aren't coders?
Good questions. For APIs, especially simulating tricky situations, there's WireMock. It's an HTTP simulator, basically a fake server.
A fake server? Why would you need that?
To test how your application handles things that are hard to make happen with a real API, like specific errors, network delays, weird edge cases, WireMock lets you define exactly how the fake server should respond. It's great for robust API testing, checking failure modes without relying on external services being available or behaving badly on command. It even has record and playback features.
Isolate your testing. Makes sense. And for non-coders?
Yeah, OpenTest is highlighted for that. It's a functional automation tool, works for APIs, web, mobile, but the key thing is it aims to not require coding skills.
Really? How does that work?
It likely uses a more visual or keyword-driven approach. This opens up automation to maybe manual testers, business analysts, people who understand the what, but not necessarily the how of coding test scripts. It still supports Selenium underneath for web testing, uses JavaScript if needed, and works with Git for version control. So you can build a test once, run it anywhere.
That accessibility sounds like a game changer for some teams.
Wow. Okay, this has been a fantastic deep dive. We've covered so much ground, from the big CI/CD players like Jira and Monday Dev to web specialists like Selenium and Cypress, mobile with Appium.
Performance with JMeter, the visual approach of SYCLX, test management with TestLink, frameworks like TestNG and JUnit, collaborative tools like Fitness.
Detailed reporting with Serenity BDD, API simulation with WireMock, and accessible tools like OpenTest. It's clear that understanding these specific features is, well, incredibly valuable.
Definitely.
So let's bring it home for the listener. If you're trying to pick an open source tool for your team or project, what does this all boil down to? What are the absolute must-consider factors?
Right. The million-dollar question. Because the best tool is always relative, isn't it? It depends on your situation.
Exactly.
The sources point to several key things. First, ease of setup and use. How fast can you get going? What's the learning curve?
Then, community support. Open source might not have formal support contracts, but a strong, active community is gold. Check forums, check activity.
Good point.
Also, the cost of training. The tool might be free, but getting your team skilled up isn't. Factor that in.
True.
Then the basics. Hardware and software needs. Does it run where you need it to? Does it support multiple platforms? Windows, Mac, Linux, and critically, the programming languages your team actually uses.
Got to match the stack.
Absolutely. Think about the project's long-term health, too. How active is development? Is there a clear support and update policy, even from the community? Checking reviews of the project or main contributors helps gauge reliability.
Okay.
And finally, something we saw again and again, integration. How well does it play with the other tools you're already using? A smooth workflow depends on this. That's vital.
That's a fantastic checklist. This deep dive really shows just the sheer power and flexibility you get with open source automation testing. Knowing the strengths of a Jira versus a Selenium or an Appium versus a SYCLX, it's not just academic. It can fundamentally change how a team ensures quality.
Exactly right. And the whole open source world, it's so dynamic. It's driven by communities, by constant innovation. These tools really do empower developers, empower QA folks to adapt and tailor their approach. It's not just about finding tools, it's about finding that freedom to build quality your way.
Freedom and customization.
Which leads to a final thought, maybe something for you to ponder.
Okay.
Given this ability, this power to modify open source tools to fit your exact unique needs, how might that really change how teams think about software quality? Could it move us beyond just, fixing bugs towards something more like truly crafting perfection?